Okay, so now we're going to take a look at trig ratios in the unit circle. So I've drawn a circle here, and let's say it has a radius of 1. And we'll draw one of those radii right there. And let's say that this radius has an angle theta with the x-axis, just like that. Now let's also say that this radius intersects the circle at the point xy. And so let's drop down a vertical leg there, and we'll draw a horizontal leg as well. And this actually makes a right triangle with legs x and y and a hypotenuse of 1. So let's take a look at the trig ratios of this angle here we've created. If we take a look at the sine of this angle, sine of theta is equal to opposite over hypotenuse, which is y over 1, which is just y. Cosine of theta is adjacent over hypotenuse, which is x over 1, which is just x. And then finally, tangent of theta is opposite over adjacent, or y over x. And this is kind of where choosing 1 as the radius of our circle comes in a little bit handy, because once again, if we just divide by 1, we get the dividend right back. So y over 1, x over 1 are just y and x. Now this applies in all 4 quadrants, 1, 2, 3, and 4. The trig ratios are still y, x, and y over x for sine, cosine, and tangent respectively, even if we go to a different quadrant. So let's take a look at that very quickly. So let's suppose we've moved theta into the second quadrant. Still have a hypotenuse of 1, and it still intersects the circle at a point xy. Now, sine theta is still y over 1, cosine of theta is still x over 1, or just x, and tangent of theta is still y over x. So let's take a look at what happens to the trig ratios here. So let's draw a little table. And in the first quadrant, we have x and y are both positive. In the second quadrant, x is negative and y is positive. That's where we are now. In the third quadrant, both x and y are negative. And in the fourth quadrant, we have x is positive and y is negative. Seeing that sine of theta is equal to y, sine of theta will be positive anytime y is positive, and it'll be negative anytime y is negative. So we can just look at this y column here and say sine of theta has the same sign at all times. So we see that in the first and second quadrant, sine is positive, and in the third and fourth quadrant, sine will be negative. Cosine of theta is equal to x, so we can do something similar with the x column here. Anytime x is positive, cosine will be positive as well, so we can copy that over. Cosine is positive in the first and fourth quadrants, and it's negative in the second and third. Tangent of theta gets a little bit tricky, but since we see that tangent of theta is equal to y over x, if y and x have the same sign, then y over x will be positive. So for example, positive divided by positive or negative divided by negative is going to come out positive. So anytime x and y have the same sign, tangent of theta will be positive. So that happens in the first and the third quadrants. In the first quadrant, x and y are both positive. In the third quadrant, x and y are both negative. So in those quadrants, tangent will be positive. And then similarly, when they have different signs in the second and fourth quadrants, tangent will be negative. So now let's take a closer look at this table here. In the first quadrant, all the trig ratios are positive, so we'll mark that with an A for all. In the second quadrant, sine is positive and the rest are negative, so we'll mark that with S for sine. In the third quadrant, only tangent is positive, so we'll mark that with a T. And then in the fourth quadrant, we have cosine being positive, everything else being negative, so we'll mark that with a C. ASTC. Now, the mnemonic I learned when I was in high school was all students take calculus. So ASTC in that order from the first to the fourth quadrant tells you which trig ratios are positive in that quadrant. In the first quadrant, it's all of them, so A. In the second quadrant, just sine, so S. In the third quadrant, tangent, T. And in the fourth quadrant, cosine, C. Hope that helps. We'll see you the next time.